Well, hi again, this is Bob, and we're getting ready to take a look at 7.4. 7.4 is not a really long section, but I thought I'd break it into two parts so I could sort of go back a little bit and try to show how all the material hangs together in Chapter 7. Remember, what we've been doing is we've been setting up confidence intervals based on statistics, and then we're trying to make an application or approximate the parameter, which can be things like the sample mean, the sample mean to the population mean, as we saw with the Z tables and the T tables. And we saw in the previous section how we can take p hat, the population sample, and apply that to the true population proportion. And 7.4 is a new distribution. It's called the chi-squared distribution. But I thought I'd just start off by a little review so we can get an idea of how this stuff indeed is all kind of one basic idea. So I'm just going to take a second and write what we've seen before. Or I should say our formulas from before. Okay, and that was basically 7.1. And in 7.2, we just had a very slight change. We had, again, the sample means, and in this case we added T sub alpha over 2 times the sample standard deviation times root n, and of course on the other side we subtracted. Okay, so we used our t-tables. Remember, this is when we have small samples or don't have the standard deviation, or there's a question about the distribution. And then the lesson that we just finished, we had the population proportion, and we used p hat, and then we had a correction of z sub alpha over 2 times the root of p hat q hat over n on the right side, and then on the left side we had p hat minus z sub alpha over 2 times the root of p hat q hat over n. Oops. Okay, so in each case we've had a confidence interval, and we've dealt with sample means and we've dealt with sample proportion. And the last lesson here, and I wanted to present it this way so we can see not only that the idea of confidence levels falls through or follows through the entire chapter, but we're going to now look at the well, it starts off with the variance, and I'm backing into this a little differently. I'm on page 401 now, but the main part of this first lesson, which will be kind of a short lesson, will be to make sure we understand how to use the chi-squared tables. That's the last set of tables we'll be presented with in our class, and they're in this case, we're trying to use a standard deviation, a sample standard deviation, to approximate the a sample variance or a sample standard deviation to approximate the true parameter, which in this case will be the variance or standard deviation. And it's the chi-squared tables, as we'll see, like the t-tables, are accessed by degrees of freedom. So I'll just go ahead and write the formula here. It's n minus 1. This is for the variance over the known, over our chi-squared left, which we get out of the table. And then on the right side, our other side for our confidence interval, we have n minus 1 S squared chi-squared right. And of course, I'll just go ahead and put the last step, and then we'll talk about using the chi-squared tables. When we root all of that I just wrote, and you can follow down on the toward the end of page 401 there, the bottom of page 401. It just basically puts a square root on either side, and we end up with that n minus 1 recalled as our degrees of freedom. And by the way, the term chi-squared doesn't mean you square it. It's a value from the table. All right, and this is the formula. Now, we may have to use the other formula, but we normally are more interested in the population standard deviation. Okay, and so what we're doing now is we're creating an interval in which we, at a certain confidence percentage, believe that the true standard deviation lies within. Okay, and so they give us a couple of really good questions on that, or really good examples over on the following pages. But we have to, first of all, understand what we're doing and how this relates to what we've previously done. We previously used we wanted to find out where the population mean lied, and then where the population, between which two values the population proportion lied, and now we're finding out between which two values the standard deviation lies. And when I say standard deviation, I mean the population standard deviation, sigma. So now that we hopefully have a general idea of what we're doing, we can go back to the beginning here. This is over on the bottom of page 398. And again, a close read, and I might even recommend that in this section that since these tables are a little different than our other tables, even though they're based on degrees of freedom like the T-tables, that you do a few of the homework problems and check yourself before going on. Some of the homework problems just are table work. Make sure you know how to use the tables before you set the questions up. Anyway, we're now dealing with something called the chi-square distribution. And it's pronounced Ki, and its symbol is kind of a stylized X squared. And they tell us that it's similar to the T-table, the T variable, in that it uses degrees of freedom. In other words, when we're dealing with our Z-tables, we're given some values and we go down, but when we're dealing with the T-tables and the chi-squared tables, they use degrees of freedom. And so if you understood the degrees of freedom for the T-tables, then it's the exact same idea for the chi-squared tables. Okay, and so remember that the degrees of freedom is equal to the sample size minus 1. Okay, and then over on the top of page 399, they tell us some things about the chi-squared tables, and it's hard for me to draw. I've got a new computer with a much smaller screen, and I don't, for some reason, my pen frequently goes off. But if you notice their degrees of freedom, and I'm just going to draw a few of them, they don't look symmetric, but they tell us that as we get to 100 degrees of freedom, that the bell, it starts looking a little bit like, or more like a bell curve, or approximately normally distributed. So first of all, they tell us that I'll go step by step here, that the chi-squared values are based on degrees of freedom, and they tell us it's obtained from the values of n-1 times s squared divided by the standard deviation squared. Okay, and that's kind of on the top of page 399. Okay, and they mention that this is used when random samples are selected from a normally distributed population, and we know the variance to be sigma squared. Okay, and then they tell us some other things that are really important about the chi-square distribution. The values, remember these are like the z sub alpha over 2, or z values and t values, but with chi-squared values, they're always positive. In other words, if this represents a stylized distribution of chi-squared values, both the values on the left and right side of the distribution are going to be positive. In other words, as they say, a chi-squared variable cannot be negative, and the distributions are skewed to the right, as we can see at the bottom of that page, page 399. And they tell us, again, at about 100 degrees of freedom, the distribution approaches a normal distribution. In other words, it's somewhat normally distributed. And then they also tell us that it's symmetric, if you will. And then they also tell us that the area, no matter what the chi-squared distribution looks like, whether it's exaggerated in one of these or we just use the stylized one, the area equals 1 also. Okay, so under each chi-squared distribution, the area equals 1, and as we approach 100 degrees of freedom, the distribution becomes somewhat symmetric. Okay, so there's a little summary of the chi-squared properties in the kind of a rectangular box on page 399. All the values are greater than 0. In other words, they're non-negative. Chi-squared distribution is a family of curves based on degrees of freedom. Okay, the area under each chi-squared distribution is equal to 1, no matter how skewed it is. And then finally, the chi-squared distributions are positively skewed, as shown at the bottom of page 399. Okay, so now they're using a kind of stylized distribution on the top of page 400, tailing off to the right there. And remember, in the past, in fact, I'll just use the example they're going to use here. Let's say that we had a chi-squared situation and we wanted to be 90% confident that our interval that we set up contains the parameter. And so remember that if we wanted to be 90% confident, or have a confidence level of 90%, we would change the 90% to a decimal, just like we did earlier, and this would give us a alpha of 0.10. And what we're dealing with in chapter 7 here is we have to take that alpha value and put it into 2 tails, divide it in 2, in other words. So if you remember the things that we've seen earlier in this section, for the z alpha over 2 or the t alpha over 2, actually didn't do much with t tables, but the z sub alpha is over 2. Alpha over 2 would equal 0.10 over 2, or 0.05. Okay, so this is what they're trying to show in at the top of page 400. You've got a 1 minus an alpha. In that case, that was 0.10, and then we cut that 0.10 area up into each tail, and it gave us 0.05 and 0.05. But there's a little different technique when we're dealing with these tables here, and that's what they're trying to show in the how to access the tables. And this is based on the fact that the tables do not have positive and negative values like our Z tables or our T tables. So here's what we're going to do if we wanted to get into the tables here. And I'll just use a fresh page for this. In fact, why don't we just go down and take a look at example 713, because it's nicely laid out and then it's nicely shown on the top of page 401, so we can refer to that. And in this case, and again, you can finish reading on the blurb on 400, but it says find the chi-squared right, and chi-squared left values for a 90% confidence interval, and n is equal to 25. Okay, now, as I mentioned, the chi-squared left and chi-squared right, those are going to be values, and you'll find them in the tables. But again, I'll go ahead and write degrees of freedom 24 here. Remember, degrees of freedom equal n minus 1. So here's what we need to do to get into those tables. The first thing we need to do is find out what our alpha is, and remember that it would be change the 90% into a decimal, 1.90. We'll just write alpha equals 1 minus 0.90 or 0.10. Okay, then we need to find alpha over 2. That's the area that gets divided into each tail, and alpha over 2 is equal to 0.10 over 2, or 0.05. Okay, here's where things start getting different now. They tell us that we take that 0.05 and we subtract it from 1. Now we're talking about the area under the curve. 1 minus 0.05 equals 0.95. So the way that we're going to access the tables, I'll just draw a little bit of the tables here. We've got our alphas, and this is in the chi-squared tables in the back of our book. And if you notice on the right side of the chi-squared distribution, we have our smaller values. Actually, I drew my line on the wrong side there. We have like, this is not quite exactly like our tables in the book, but I'll show that again I wanted to show that there's symmetry here. Okay, so we start off with like 0.10 and then 0.05 and then 0.025, etc. You can even show 0.01 there. Okay, but notice on the right side of the tables, I'll just put a few of them here because I wanted to point out that we have like 0.90 and 0.95, and the next one would be 0.975. I wanted to point out that there's symmetry here. In other words, the line, at least in the previous text, that separates the right side of the tables from the left side of the tables can be thought of as like a symmetry line, because if you notice, when you go one step to the right of the symmetry line, you get 0.10, and one step to the left gives you 0.90. Those are complements of each other. If you go 2 steps to the right of that line, you're at 0.05, and 2 steps to the left of the line, you're at 0.95. And of course, 3 steps to the right of the line is 0.025, and 3 steps to the left is 0.975. They all add to 1. Okay? So the next thing that we're supposed to do is notice that the table is divided when we divide it like that, that this is the right side of the table and this is the left side of the table. And that helps us understand chi-squared right and chi-squared left. Okay, so the next thing that we're supposed to do, and there's something else that you'll notice here when we get to the equation, but if you notice, the larger values are going to be on the right side and the smaller values are going to be on the left side. But anyway, let's go ahead and do this. Remember what we did. We found 1 minus 0.90, and that gave us 0.10 for our alpha. And then we went alpha over 2 is equal to 0.10 divided by 2, or 0.05. And then to get our areas and to get into the tables, we went 1, which is the area, again, of the entire under the chi-squared distribution curve, minus 0.05, and that gave us 0.95. And that means that to get into the tables, we need the values of 0.05 and 0.95. And of course, these values are complements of each other, and the 0.05 will be found on the right side of the table, and the 0.95, its complement, will be found on the left side of the table. This gets a little, it takes just a little getting used to here. So now we'll get down to where the book's at. Just remember how those values were obtained. We took the alpha of 0.10, we cut it in half, and we got 0.05, and then we subtracted that from 1, and it gave us 0.95. Okay, and those are our two values. So our chi-squared right, if you go down, now we need our degrees of freedom, and the sample size was 25, so our degrees of freedom will be 24. So let's get our chi-squared right first. For 24 degrees of freedom at alpha 0.05, chi-squared right is 36.415. Don't round off, use the exact value they give us. And chi-squared left, which is on the left side of the table, is 13.848. All right, so this is our chi-squared right, and this is our chi-squared left, and those are the two values that we're going to plug into the formula over on page 401, and which I introduced earlier. So let's close off this kind of a short section here. And again, you may want to do a few of the homework problems because I gave you some homework problems that specifically concentrated on using and mastering the table, and it was question 3. Okay, question 3 has 5 questions, and they all involve finding chi-squared right and chi-squared left on the tables. Okay, so we'll finish off on this over on the top of page 401, and I'll put it in the order they did. Lost my pen. Okay, 36415 and 13848. Okay, and this is their representation. All right. And they went ahead and shaded these in. Okay, and then they tell us a little bit about using the degrees of freedom, but I'm going to put these two values on here. And I'd like you to notice that when we look at our graph there, we can see a pretty good situation in terms of the 100% of the graph. And if you notice, we've got like I'm just going to draw here. To the left of this 0.05, this 0.90 and that 0.05 add up to 0.95, as it does in the other direction also. And notice that both of our chi-squared values, as chi-squared values always will be, they're non-negative, which is like saying they're going to be positive. Okay, well, the only thing that we would need to do, and again, the 0.90 is the area under the chi-squared distribution in which we believe our sample will fall in, our sample standard deviation, which we're setting up as a confidence interval to find the population standard deviation, and that's the confidence level that we'll feel that our sample falls within. Okay, and of course, these two values here will be plugged into the formula directly below them on page 401. Okay, and then they also tell us that one final thing here. If you recall, when we went into the t-tables, if we had a number that fell between, when we get the larger values or larger sample size or degrees of freedom, that we always went to a lower one. In other words, I think we used, for example, we had degrees of freedom 68, and in the chart, this is for our t-table, we could have gone to 65 or we could have gone to 70. The book told us to go down and use 65 degrees of freedom because that would give us a larger value and a larger interval. Where they're telling us the exact same thing about the chi-squared values. They say if we had, when we're talking about chi-squared, if we had 53 degrees of freedom and we were able to, let's say for example that they had a chi-squared for 55 and for 50, we would go down and use the chi-squared value for 50 because that would give us a larger interval, and we would, when we're trying to figure out our certainty. Okay? So like they said, it's a more conservative approach. Okay. Well, I will be back shortly, and they give us two really good questions on chi-squared applications, and it's example 714 and example 715. And there's just one little thing that we have to watch out for, which I will always highlight whenever we have like a test question or something on chi-squared values. Anyway, I will be back shortly with that. Thank you.